All right. For the final part of the lecture, we should be getting into some familiar territory for you. So we're not following logical rules. What are we doing instead? Could you say that we're just being stupid? Well, not really. If you're saying we're being stupid, then it's also stupid to follow decision rules or using contextual. We're fooled by contextual information. So we're so trained by getting an impression or making our choices, having attitudes on the basis of contextual information, which is a very efficient way of coming up with attitudes and responding to information, that we have difficulty letting that contextual way of thinking go when we're asked to come with a logical judgment. Which isn't that different from the fact that people perceive the moon to be larger when it's nearer to the horizon. It isn't in actuality, but it seems that way because it's closer to the foreground. So it's, that different context gives you a different perspective, which isn't different from this illusion that you're familiar with, being that the lines are of equal size, but they seem to differ because of the context. And these blue dots are of equal size, but they seem to differ because of the context, right? What happens is that objectively we're wrong because we're using contextual information. That doesn't mean, as in perception, as in coming up with our attitudes and our decisions, that doesn't necessarily mean that we're being stupid. No, we're using a very useful and efficient tool, using contextual information to come up with decisions. So what we're doing when people ask you to decide or judge a thing, we're not using the normative judgment, which would be following the logical benchmarks that we indicated. No, we're coming up with an intuitive judgment, which is context-based. So if somebody asks you what are the odds that this plane crashes, we're not calculating relative frequency, which would be the way of calculating the objective probabilities of your plane crashing. No, we're thinking intuitively, how easy is it for me to think about instances of planes crashing? Which is very efficient, which is a way of using heuristic to come up with judgments. And we have a couple of examples about that, which should be familiar to you on what you talked about last year. But I just want to reiterate that to refamiliarize yourself with that theory about how we actually make decisions. We're not following logical rules, we're using heuristics, which is efficient, but might lead to bias in some instances. So, one of these biases is the good result from using the representativeness heuristic, which is illustrated here. So some people believe that a carrot is good for your eye because if you slice a carrot, it kind of looks like an eye. Or tomato is good for your heart because if you slice a tomato, it kind of looks like the four chambers of your heart. Or a walnut looks like your brain, so it must be good for your brain. Celery, if you chop it up or look at a slice, it kind of looks like your bones, so it must be good for your bones. Which are all examples from the fantastic site God's Pharmacy is Amazing. What's also amazing is that God's Pharmacy is Amazing is printed in Comic Sans. So that's interesting in and of itself, but it's all examples of overuse of the representative heuristic, which means that if there is a match between two things, it's more likely that those two are related. So you're familiar with the gambler's fallacy. So if you ask somebody, here's a roulette wheel and we had 8 instances of the ball landing on red, what do you think would be the most likely next outcome? Most people would say black would be the most likely next outcome and would put their money on black. That is the belief that it's more likely for a random outcome to correct itself if it seemed dissimilar from what we consider a random process to be. So a lot of red in a row we see as not representative of a random result. So we think it must correct itself soon by landing on black. So we're fooling ourselves based on representativeness. We're thinking randomness looks like red, black, red, black, red, black, red, black. That sequence would be representative of randomness. What we're seeing is red, 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 red. That isn't very representative. So if the roulette wheel is fair, then that must correct itself. So we do get to an instance or a good example of a random sequence. Representativeness is also used to explain why people have the hot hand belief. So the belief that if a basketball player lands a lot of free throws in a row, it becomes more likely that they will land the next throw as well. They believe that people have a hot hand, and they believe that landing a couple of shots in a row is not representative of randomness. It must be representative of something else, namely a hot hand. So the next row would be more likely to be yield points than be a miss. Okay, so we're going to look at 3 heuristics, so bear with me. We're almost at the end. I'm struggling in managing time, as you see, will improve along the way. We're almost at the end. I want to talk to 3 heuristics with you. So there are 3 ways in which people take shortcuts in reasoning, which are efficient shortcuts to be sure. And in most cases, it will give you good enough results, but sometimes it can lead to errors. So we talked about representative, and we can talk about availability bias. So there was a rumor about McDonald's. There's always rumors about McDonald's, but in the 80s, there was a rumor that McDonald's didn't use meat, but worms as fillers for their hamburgers. And McDonald's tried to counter that rumor because it led to decreased sales by posting notices and giving informational campaigns by saying, well, it would be irrational for us to use meat, to use worms, because they're more expensive than using meat, weirdly enough, but that apparently was true. So there's no reason for us to use worms because meat is cheaper, and so that's rumor, it's not true. Which led to a further decrease in sales, because what actually happened is that McDonald's, with this campaign, made the rumor more available. They're saying, hey, have you heard of this rumor? It's not true. Have you heard of this rumor? It's not true. Which means that you're actually reinforcing the rumor as well, because people are more likely to rely on the availability of information. So do you think it's true? Well, I kind of recall hearing a lot about that rumor, so perhaps it's true, right? So you're using that availability heuristic. How available is that rumor in this instance, or another example in your memory, you're using as a shortcut for judging probability. Which is the availability bias. It can lead to mistakes about McDonald's rumors. It can also lead to mistakes in your actual relationship. So perhaps that's useful to know about the availability bias. So if you ask people in a relationship or in the same household or in a work group what they contributed to the whole, so what was your contribution to the household in percentage? So I'll take out the trash, I do the laundry, I do the ironing, etc. So that must be about 60% of all the stuff we need to do together. And if you ask that to all partners in the household and you add those percentages together, that total would exceed 100%. So people overestimate their own contribution to the household. The reason why they overestimate their own contribution to the collective effort is because instances of you doing stuff is more available to you than instances of your partner doing stuff or your tutor group partners doing stuff. All right. We talked about 2 examples, 2 heuristics that people use, right? So we talked about representativeness and we talked about availability. Useful tools for coming up with estimates about probability, but it could lead you to be biased in certain instances. The third and final one is anchoring and adjustment. So a useful way of coming up with an estimate, if you know nothing about, about which a judgment is being asked, is anchoring on the information that's being given. So what that means is that if somebody asks you in a jury, for example, would you award a penalty in a range from $15 to $50 million or $50 to $150 million, in both cases, depending on what number you hear, if you wonder as a juror what penalty would be more acceptable in this example, well, they're mentioning 15 to 50, so I start with the 15, but I don't think it should be judged that hardly, so I think it will be 20 million. But people hearing the 50 to $150 million estimate given by the lawyer, they would do the same reasoning, but they start out with 50. So, okay, so what the person did wasn't that bad, so it shouldn't be too harshly punished. So we start with 50, and I'll end up somewhere at 70 million. So somebody, depending on the question you're being asked, you are more likely to think that a penalty of, what did I say? $20 million is in order, or $70 million is in order, because you're anchoring on the information that's being given. And we do this with ridiculous examples as well. So even this is very persistent bias. So people, even if they know that they're being biased, or if you know that you anchor on available information, it's very difficult to correct for it. Even if the information given is patently untrue. So if you would ask people, was Mahatma Gandhi younger or older than 5 years old when he died? It should be clear that that value of 5 year old is very unlikely to be his true age when he died. People would come in that example, in that condition, they would come up with a lower age estimate than if people were being asked, do you think Mahatma Gandhi was older or younger than 120 years old when he died? In both cases, you're giving an anchor, a number, an age number to anchor on, which is in both cases clearly untrue. He wasn't 120 and he wasn't 5 years old. But it influences the estimate that people truly give. They say, well, he was older than 5, and I think he was 30 years old in the first condition, and they're more likely to say, no, of course he wasn't 120 years old, he was younger than that. I think he was 80 years old in the second condition. So in both cases, you're following the same reasoning. You're using the number given as an anchor, and you adjust from there, which has an influence on your actual judgments. So you're more likely to think that Mahatma Gandhi died young in the first condition, and you're more likely to think that he died old in the second condition, even though you know the numbers you're anchoring on are clearly untrue. All right, so what we talked about is that people are not rational in the decision making. They do something else. What they do is using heuristics, which are time-efficient ways, time-efficient shortcuts for making decisions. Now that we know this, we also know how we can be fooled, depending on the context in which we have to make a decision. We better understand why why people aren't always trying to convince us by using proper reasons, but also by using something else. Because we're sensitive in responding to that context, to that something else, to the associations we have, the available information that comes to mind when viewing images or when hearing Martin Luther King describe how the world could be in our future. We're sensitive to that because we use those decision shortcuts, because they're efficient, and they're usually an efficient way of making proper decisions, but they sometimes open us up as well for being influenced in an improper way, as in advertising. Or when people use rhetorical ploys in their language use, as well as actual reasons. That might be a way in which you're being unduly influenced as well. All right, so what we talked about today is that it's important to translate unclear language into clear propositions. We started out with that. We started out talking about Bill Clinton, you remember, and vagueness and ambiguity, and the meaning of what the meaning of the word is. We talked about that people are irrational, tried to convince you that people are irrational, but I can only convince you that people are irrational using these benchmarks of rationality. And you, being a critical thinker, you might be more likely to think, hey, is that really what I mean when I talk about rationality? Think about that for yourself. I mean, it's not important for this course, but you could think that perhaps it's more rational in the way you understand the term to be efficient in your thinking and decision making. Then it would be very rational to use heuristics, which might sometimes lead to bias, but not a lot. So let's call that ecological rationality, right? Using heuristics to make decisions, which is efficient and which also means that we're sometimes wrong. And for you, developing a disposition, critical disposition, it's important to recognize under which circumstances you might be fooled by using those heuristics. And it's useful to know how we fail to live up to those 3 different benchmarks of rationality, because next week we're going to talk about logical assessment. So how do you assess the logical structure of an argument? And for that, you have to be somewhat more fluent in logic and probability. So we're going to talk about logic and deductive validity, the first part of logical assessment, on Tuesday. And we're going to talk about probability and inductive force on Friday, which is the second part of logical assessment.